I'm going to let that sit up there for about a minute so you can take the information in. Okay, so we're starting out with something two-dimensional, a rectangle with a length that is 8 inches less than twice the width, so we're taking away 8 from 2W, and I want to show you here in a moment just what's going on with this idea of splitting things up. So I'm going to show how we're cutting out those 4 inch by 4 inch squares from each corner and folding it up, going from something two-dimensional to three-dimensional. So here we go. We've got the rectangle with a width of X. So I'm going to change that W over there to an X. Therefore, the length is 2X minus 8. Making the change on the board over here so I don't forget. And I've already marked out where the 4 by 4 inch square is going to be, each corner. I'm going to cut those out. I'm cutting 4 inches from each side. So 4 inch by 4 inch square there, gone. Same on the other corners as well. There's 2 of them down. Third one's about to go. And then the last one here. Okay. Well, what we're left with then is not rectangular anymore. We've got portions of rectangles joined together. Also, we don't have the dimensions we used to have. We just took out 4 by 4 from each corner there. So what's been removed, if you look at each side, for example, of that length, 4 on the left, 4 on the right, for a total of 8 taken away. And it's the same over here. From that width of X, we started out with the whole thing being X inches long, and now we've taken 4 away from this side and on this side for a total of 8 inches taken away. So if I flip this over, we've got X minus 8 over here, and originally we had 2X minus 8. We just took away 8 from each side there. So we have, for this large rectangle inside, we've got dimensions X minus 8 and 2X minus 16. Well, what they're talking about is folding After we cut out the corners, we can fold up the little rectangular sides here. And make a box that does not have a top. To find its area, we would take the length and the width of the base multiplied, sorry that's backwards, but multiply it by the height of the box. So we're going to have 2x minus 16 by x minus 8 by 4. And I'm going to write the 4 in front. So based on what we saw from folding things up, as I said, we have a length of 2x minus 16 now, a width of x minus 8, and a height of 4. Plugging those in to the volume formula of length times width times height, as well as the fact that we know that the volume is 1,352 cubic inches, then rather than multiplying this out, I'd like to see if we can make things a little bit nicer, because I noticed as I took away 8 from the 2x minus 8 and got this, that was double this. I could factor out a greatest common factor of 2. And we've already got a 4 out there. It's going to give me an x minus 8 and the other x minus 8 we originally had. The 4 times the 2 is 8, and the 2 copies of the quantity x minus 8. Could rewrite that as that quantity x minus 8 being squared. If we then divide both sides by 8, we get that the quantity x minus 8 squared is 169. Seems to me this application is a good candidate for using the square root property. So it's going to cancel on the left. Plus or minus the square root of 169, which is 13. If we take the 8 and add it, the subtraction case would give me 8 minus 13 is negative 5. That makes no sense because our comparison of length and width was in terms of inches. The square pieces that were cut out were 4 inch by 4 inch, and the volume was in cubic inches. Negative 5 inches for our width does not make sense. So W 8 plus 13 is going to give us 21 inches, and the length, twice that, minus 8. 42 minus 8 is going to give us 34 inches.